morning, everyone. I think I can start class now. First thing I want to remind you, we have some online homework this week. That is the section 10.6, section 10.7 due on Sunday this week, and we have the interactive review. Let me see. We have no interactive review this week. We just have 10.6 and 10.7 due this week. And today we will move on to the new section in this chapter, section 10.6, the G-square test for goodness of fit. Okay, and the first thing, when we talk about G-square test, I have to talk to you about the motivation, why we have to study, why we have to learn G-square test, why we have to do this. And the motivation here, I will consider the following situation. For example, suppose that I want to test if a six-sided dice is actually fair. What does it mean? That means that when I roll the dice, six-sided dice, I expect to get the values of 1, 2, 3, and 4, 5, 6 are equal, have equal change. That means I want to test the dice is actually fair or not. Okay, and to do this, I will do the experiment. I will roll the dice 100 times, and I expect that because you have six sides, you have six values, right? And I have 100 times to roll the dice. 100, and I expect that we will have 100 divided by 6 is approximately 17, and I expect that for each value, right, 1, 2, 3, 4, 5, 6, we have 17 times to wrap this value, right? And that's I expect if the die is actually fair. Okay, but in fact the result in our experiment will not like this. You can see in the slide we have the number of dice in 1, 2, 3, 4, 5, 6, and here is the number of times it appears. Maybe 1 is 17, 2 is 18, 3 is 8, and 4 is 14, and 5 is 25, something like this. And it's not like its value is 17 times, right? And the question here is, are the result here close enough for the dice to be considered fair or not? Okay, how do we evaluate it? How do we make a decision in this hypothesis? Okay, to answer this question, we will use the hypothesis test with a G-square test to make the decision about this. Okay, we will make a decision about if this die is fair or not fair. Okay, and this is the motivation for today. We will learn the method of G-square test to test these hypotheses. Okay, and to do this, to do the method, I have to talk about what is the no and what is the alternative hypothesis in these examples, in this situation. Okay, I will consider the example here. The example here is the roll a die, right? Roll a dice. Six-sided die. Okay, and I want to check. I want to know. We want to know if the die here is fair, okay, or not fair. In the means as I mentioned you before, and after that we will have two hypotheses. The first hypothesis, and in the previous class is called no hypothesis, and H on front here is the alternative hypothesis. And in this case, we want to know if a die is a fair. That means that the probability to get 1, to get 2, to get the value 3, to get the value 4, to get the value 5 and 6 are equals, right? That's either the null hypothesis. That means the probabilities to, okay, I get P1 here, T, the probability to get the value 1 and probability 2, that means we get the value 2, and P3, P4, P5, P6. Okay, that's the null hypothesis. I want to get the change of the values are equal. Okay, what the probability to get the value 1 is equal to the probability to get the value 2, something like this. And all the probability here are equal. That means this is the die here is fair. Okay. That's the null hypothesis. And the alternative hypothesis is different from the null hypothesis, the opposite side. That means there is some difference among the probabilities. There is some difference among these probabilities. That means the probabilities to get the value 1 is different from the probability of get value 2, something like this. And one thing to remind you when you learn about probabilities, that means the probabilities of all the value here must be, do you notice? The sum of these values, the sum of the probabilities of all outcomes here should be, do you know the value here? It should be 1, right? It cannot be greater than 1, it cannot be less than 0. And it must be equal to 1. Because the probability to get the one value when you roll the 6 side is 1 over 6. You get 2 values 1 over 6. 3 values 1 over 6, 1 over 6, 1 over 6, 1 over 6. And after that you plus all together. And the values here is 1. The sum of the probabilities is 1. Right? Okay. And that's either null and alternative hypothesis. That's you can look at in the stream. That's either null and hypothesis or null and alternative hypothesis when we talk about this situation. Okay. And now we will learn how to evaluate, how to do the test, hypothesis test with these problems. How we do this. Okay, how we do this. And here is the method. Before moving on to the method, today I will need to talk to you about the condition to apply the method. When we talk about this, we need to talk about requirements to apply this method. We have 3 conditions, okay? 3 conditions. The first one, the sample data are randomly selected. That means when you choose a sample, you need the change to choose the samples are equal. Okay. Then you can look at this in chapter 3. And the calculations are used frequency counts of the data for each different categories. Okay. What does it mean? As you can see in the table 10.2, that means we will count the frequencies. To get the value 1, to get the value 2, we will use the frequency. For example, the numbers on die, the value 1 is 17 times. So we write 17 times. That means we have to know these information. If we don't know this, we cannot apply this method. We have to know the frequency. That is the second condition. We have to know the frequencies. Okay? That is the second condition. We have to know the frequencies. And the final condition here, the expected frequency for each category is at least 5. At least 5. As you can see in the table here, all the value here are greater than 5. Okay, so these conditions are satisfied. Okay, is it clear, guys? That's either the three conditions. We have three conditions here are satisfied. The frequency will be at least 5. Here we have 8 here, that's 5. So we need to check the condition before you apply this method. Okay, you need to check this condition. Any questions so far about this? That is the condition to apply this method. The sample data is randomly selected. Calculation yield frequencies. We have to know the frequency and the final one, the expected frequency at least 5. Okay. That is the condition to apply these methods. Okay. Okay. And that is the condition. So now I will give you the method to check these, to test, to give the hypothesis test of G-square test for this kind of problems. Okay. Okay, we have the formula here. The test statistic formula here is G-square. G-square here, for example, G-square here is denoted by this notation, and will be calculated by sigma of the OI minus EI squared over EI. So I will show you what does it mean. What does it mean? OI here is the observed frequency for I possible outcome, and EI is the expected frequency for I possible outcome. Okay, so when you look at this, maybe you will confuse. And you can look at the table 10.2. Okay, 10.2 here. We have the table 10.2 here. In this case, we have 6 values. Okay, we have 6 values. That means the sum here will be from I to 6. Okay, we consider example at the beginning. We have 6, right? We have 6, right? 6 values of the dice. In this case, the G-square will be calculated by O1 minus E1 squared over E1 plus O2 minus E2 squared over E2 and plus O3 minus E3 squared over E3 and plus O4 minus E4 squared over E4 plus O5 minus E5 squared over E5 and plus O6 minus E6 squared over E6. That's the meaning of this equation. This is the meaning of this formula. And what about O1, O2, O3, O4, O5, O6, E1, E2, E4, E something like this? How do we know this? Okay, let me look at the formula here. OI here is the observed frequency. You look at the keyword observed frequency. Observed frequency. That means this frequency you observe from the experiment, right? So you can look at the table. Okay, this is the observed frequency. This is observed frequency. When you do the experiment, you get 16 times to get 1, 18 times to get 2, 8 times to get 3. That is observed frequency. Okay? This is the observed frequency. So could you tell me what is O1 here? The O1 here is the frequency to get the value 1 on the dice. So could you tell me what is the O1 here? What is O1 here? O1 here is observed frequency when of the value 1. Okay, you are author, right?
Yes, that'd be 17 and 100.
Yes, 17. No, 17. That's the frequency, not the probabilities. The frequency. The frequency is 16 times. Okay, the frequency is different from probabilities. Okay, so frequency here is 17. Okay. What about the frequency to get the value 2? That's the O2. Right? What is O2 in this case? Okay, Trivia, right? 18, yeah, exactly, 18. So similarly, you can guess the observed frequency for the value 3, observed frequency for the value 4, observed frequency for the value 5, 6, something like this. Okay? And then you clear, right? You can determine what is O1, O2, O3, O4, O5, O6 in this case. Any questions so far? Okay, that's the observed frequency. The observed frequency will be taken from the tables, the experiment table. Okay, when you do the experiment, you will have the table to get the result, right? In this case, the O1, O2, O3, the observed frequency will be taken from these tables. Okay, that is the observed frequency. How to get the EI here? The EI here, that means that is expected frequency. The expected frequency. Okay, how to get this? The expected frequency will be calculated. It's not come from the table. The EI frequency. How to calculate this? Okay, I will erase here. I will erase here. So we have the observed frequency that will fit us this kind of questions. Frequency, that means O1 is equal to 17, O2 18, O3 is 8, O4 is 14, O5 is 75, O6 here is 18. That is observed frequency. Now we will talk about the expected frequency. What about expected frequency? As I mentioned you before, you want to check if the dice is actually fair. That means the probabilities of the value 1, 2, 3, 4, 5, 6 are equal. That means that when you roll the die 100 times, so you will expect for each values on the dice would be 17, right? So the expected value here, that means you want to order all the value here are equals, and it will be 100 over 6 because you have 6 values. You have 6 values, and you have 100 times to roll the dice. So the expected frequency will be calculated by the number of times, the total number of times over 6. That means, in other words, it's calculate 100 times to probabilities. Probabilities here. The probability here is 1 over 6. So it means that it's approximately 17. So that means that we expect the number of dice, number 1 is 16 times, 2 is 17 times, 3 is 17 times, 4 is 17 times, something like that. We expect all the value here are 17 times. That's the expected frequency. Okay? Expected frequency. This is observed frequency, that is expected frequency. Okay. This is in the theoretical aspect. Okay, that is theoretical. And this is practical. That is the theoretical, and this is practical frequency. Okay. And now, that's the meaning of EI here and OI here. OI here is the observed frequency. EI here is the expected frequency. Okay. Any questions so far about observed frequency and expected frequency? Okay. Help you guys understand about the observed frequency and expected frequency. Okay. When we know about this, when we know about observed frequency and expected frequency, you can calculate the chi-square test statistics Oh yes, you can calculate the chi-square test statistic by using this formula. Okay. Use the formula, you can find chi-square here. Okay, you can calculate by using this one. And this is calculate O1 minus E1 square over E1 plus O2 minus E2 square over E2 and plus O3 minus E3 square over E3 plus O4 minus E4 square over E4 plus, okay, you can do this O5 minus E5 over E5 something. That is chi-square test, and you release all the value to this one and using calculator to calculate it. Okay. And what is the role of chi-square test statistic here? We will talk about later. We just know how to calculate chi-square test here, and we will use it for hypothesis testing. We will talk about it later. And now I just give you the formula for this. How do we use it? And we will use this to evaluate for the hypothesis testing. We have two conditions here. If the chi-square is less than chi-square alpha, then we fail to reject H0, the null hypothesis. If chi-square is greater than chi alpha square, then we will reject the null hypothesis. What about this? How do we calculate how do we find the chi-square alpha? How do we find it? In this case, you will use the table critical value of chi-square. So if you have the textbook, we will find this in the page 816. I will write down here. Okay, we have two conditions. I will write down what is the role of chi-square. Okay, so we have two conditions. If chi-square is less than chi alpha square, then we fail to reject the null hypothesis. If chi-square is greater than or equal chi alpha square, then we will accept or we will reject the null hypothesis. We have two conditions like this. And the question here is, how do we find this? Okay, that's my question. How do we find this? We will use the tables. Okay, use the table 3 in the page A16. So I also give you the table on the page 2. Here you can find out in the page 2. I also give you the table for this. Okay. When you have the chi-square alpha, you can compare with the chi-square you have found. Okay. How to find this? To find chi-square alpha, it depends. Chi-square alpha will depend on the DF value and the significance, the level of significance. Okay. So it depends on the value DF, and the alpha here is the level of significance. The level of significance is often appear in your questions. They will give you the significant level of significance. And how to find DF? To find DF, that means the number of degree of freedom. That's calculated by this formula. DF is equal to K minus 1. K is the number of possible outcomes for each trial. For example, in this example here, we have 1, 2, 3, 4, 5, 6. We have 6 value, right? We have 6 value. In this case, DF here. Okay, we will go back to this example. I will erase these. You look at the example here. In this case, we have k equals 6, right? Because we have 6 values. And in this case, we have the df here is k minus 6, that is 6 minus 1 equals 5. Okay, assume that alpha here is, I give you 0, 0, 5. So could you tell me what is the g alpha square? What is g alpha square? By using the table. So you will look at the table here. Look at this row and find df here is 5, right? df is 5. And you look at the column here to find the value 0, 0, 5. And after that, you make the intersection between them, and you can find the value for the sigma g square alpha. Okay, could you tell me what is the value of g square alpha in this case? Okay, Liz, please. 16 point. Let me see. 0, 0, 5. Okay. 16. Okay, not 16. So you can look at this. Df is 5, right? Df is 5. So you look at the 0, 0, 5 here, and after that you make intersection. It's not 16. Okay, Delaney, please.
11.070.
Yeah, exactly. So you can look at the 5 here and look at the value here. So you can find this value here is exactly okay, 11. Okay, this is the value for g alpha square. Thank you, Delaney. Basically, guys, that is the way to find the g square alpha. If you know the level of significance and you know df here. So g square here is this value. Okay. And after that, you will check this value with the g value. Okay. If the g value is less than g square value, that we will fail to reject the null hypothesis. If the g square is greater than or equal the g square alpha value, so we reject it. Okay, that is the way to do this. Okay, that's all the things about g square test. So now I will give you an example to do this. To do example, so you will understand more. You can look at the example here. Look at the example here. Any questions so far about this? Okay, so now we look at the example here. A local bank who wants to evaluate the usage of its ATM. Okay. And currently, the bank manager assumes that the ATM is used consistently throughout the week, including weekends. And after that, she decides to use statistical inference with the 0.05 level of significance to test a customer claim that the ATM is much busier on Sunday of the week than its other days. Okay. The first here is the experiment of her experiment. They give and she investigate the survey, and after that get the result like this. In Monday, the number of times used the ATM is 38. Tuesday is 33, Wednesday is 41, Thursday is 25, something like this. That is the experiment from her. And we will, the first step here, we will say the null and hypothesis. The null and alternative hypothesis. Have x0 here and x alpha here. And okay, this is the null hypothesis. The bank managers assume the ATM is used consistently throughout the week, including weekend. That means that the probability to use the ATM on Monday is equal the probability to use ATM on Tuesday, on Wednesday, on Friday, something like it's equal, right? That is the null hypothesis. B1 equal B2, B3, B4, B5, B6, B7. Okay, this is my mistake when I typo. So you can write down here is B6, B7. It's not like B6, it has B7 here because we have 7 days, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We have 7 days in the week, so it's equal to B7 here. This is my mistake when I type. Okay, we have 7 days in the week, so the probabilities of the Monday to go to Monday is equal to probability to go on Tuesday, something like this. That's the probabilities. Okay, and the alpha, the X alpha here is there is difference, some difference between them. Okay, so we don't need to write this. Okay, let's see the step 1. Okay. This is the mathematically, so this is B6, B7 here. I thought this is my typo mistake. Okay, let's write down here. It's B7. Okay. That's the null and hypothesis testing. Okay, step 2. We will study the level of significance. The level of significance here. Could you tell me what is the level of significance here? Okay, Maria, please. Yeah, exactly. The level of significance alpha here is 0.05. Okay, thank you. Okay, that is step 2. And step 2, sometimes we need to check the condition. Okay, you saw that we have to check the 3 conditions. The sample here is random selected. Okay, that's fine. The calculation use frequency. Okay, that's all the frequency, right? And the expected frequency for each category at least 5. Okay, exactly. We don't need to care about this. Okay, check 3 conditions. And step 3. And step 3 here, we will calculate the sample statistic. We calculate the t-square statistic. T-square statistic. T-square statistic and T-alpha square statistic. Compare that. Okay? How to calculate this? Okay, T-square statistic here. Okay, you can look at the screen here. This is T-square. We have 7. We have 7, right? We have 7 values, right? So the sum here is like this. I will write down for you to understand or look at the table here. So we need to determine what is O1. Okay, O1 is the observed frequency. Observed frequency to use the ATM on Monday, right? Okay. So could you tell me what is O1 here? What is O1? Okay, read please. 38. Okay, 38. So similarly you can find all the observation. Well, not observation. This observed frequency. O1 is 38. So O2 here is 33. O3 here is 41. O4 here is 25. O5 here is, let me see, 22. O6 here is 38. And O7 here is 45. So we have this is observed frequency, right? Okay. And what about the expected frequency? The expected frequency are equal because the X0 here is B1 equal B2, B3. So it's equal together. 65. And it's equal to, okay, so it's equal to N here over to 7. What is N here? N here is the number of times number of times used. Okay, the total number of times used. So we have is the number of time here is 38 plus 33 plus 41 plus 25 plus 22 plus 38 plus 45. So could you tell me the number of times she did this experiment? So you can find n here. Okay, Maria, please.
242.
Okay, 100.
242.
Yeah, 42, right? Yeah, exactly. That is the number of times she did the experiment. Okay. And after that, because you have 7 values, so n over 7, that means this number, right? This number. And when you have O1, O2, O4, O3, and E1, E2, so you relate to the formula, and you will find chi square is calculated by this formula. Chi square here is calculated by this formula. O1 here is 38, right? Okay, you don't need to round it this value. You keep this, okay? Keep this, and after that you round it back later, okay? Don't round the value at the beginning, otherwise you will get the error. You get error when you make the calculation. So keep it. It's in the fraction. Keep it in fraction, and relate to this formula. Okay. And you notice E1 here is this value. E1 here is this value. E1 here is this value. So relate O1 here, O2 here, O2, O3, O4, O5, O6, O7. Relate to this. Okay. And after that, you use calculator. And the value here is 12.314. That is the value of chi square. Okay. I'm going to write down here. Chi square here is approximately this value. Okay, chi square is approximately this value. Any questions so far? This is the way to find chi square. And when you know chi square, you need to find chi alpha square. Okay, I will erase this step 1. On this one I need to find this one. So we have alpha here is 005, right? 005. And what about df here? Df is k minus 1. K is the number. We have 7, k is 7 here, right? K is 7 here, so 7 minus 1 is 6, right? Because we have the 6 outcome, we have the 7 outcome. The outcome here is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. We have 7 outcomes. So df here is 7 minus 1 is 6. That's in the df, right? And now, could you tell me what is the chi alpha square here by using the level of significance and df here? Okay, Lee, please. Let me see. Okay, let's go. Okay, 12.592. Oh, exactly. Thank you. Okay, so you use the table here. Use the table to find the F is 6 and 5005 here. And after that, make the intersection between them. Okay, and you will get the result. Okay, you get the result here is 12.582. And you see, okay? Okay, exactly. And after that, when we find chi square here and chi alpha square and compare them, so could you tell me, chi square is greater than or chi alpha square, or chi square is less than chi alpha square? Compare them. Could you tell me? Chi alpha square is greater than chi square or opposite side? Okay, we have here chi square is this value, right? So it's less than this value. Okay. So that means the chi square is less than chi alpha square. So with the decision we make here. Okay, Arthur.
You accept the null.
Huh?
You accept the null.
Okay, accept or fail to reject. Okay, we don't use the accept the no hypothesis. We will use the concept we fail to reject. Some textbook they use the accept the no hypothesis, but in our textbook we don't use the accept. They use the fail to reject. Okay, that means you fail to reject the no hypothesis. Okay, thank you. Any questions so far? That is the way to evaluate, to make the chi-square hypothesis testing. Okay, if you don't have any question, so we go to some practice exercise. Okay, that will help you to do some homework. Okay, some exercise homework. Okay. So we go on the question 1. We find the critical value of chi squared. That means they ask you to find chi square alpha. Okay. And find chi square alpha. This kind of homework this kind of question help you to practice how do we find the chi alpha square by using the table critical value of chi square. That is just like this. This is the purpose of question 1. The question 2 is they give you the chi square and they ask you to find the chi square alpha. And after that they ask you to make the decision, fail to reject no hypothesis or reject hypothesis. The question 3 is some kind of practical problem. You need to translate this kind of problem to the mathematics problem, mathematics statics problem, and after that using the theory here to test. Okay? That is some kind of problems. I write down here to you to practice, for you to practice. It's not the assignment. It's not assignment. It's just the practice exercise for you to understand the material here. Okay. So we have alpha here is 0.1 and k here is the number 47. So could you tell me what is the chi alpha square here? So to find that we need to inline df here. The df here is k minus 1. So k minus 1 is 46, right? Okay, so you check the table, find the chi alpha square, okay? Okay, we don't. We have the value here. Okay, we don't have value here. Let me see. So why we don't have the value here? So maybe. Let's see. I don't have the value here. Why? Let me see this. Okay, so why I don't find a value for df here, so my mistake maybe it's my mistake when I write the exercise here. So okay, so forget about it. Maybe my mistake when I write the question 1 is case not 47, so you don't need to care about the question A because it's not in the table. Okay, so don't care about it. So we just focus on the question B. Okay, this is my mistake when I look at this, so I don't care about this. K is 22, so the F here is 21. Okay, so you can look at this to find out what is the critical value for the chi alpha square here. Could you tell me what is the critical value for this? Okay, Maria, please.
32.67.
Okay, exactly. Okay. Okay, let's see. Okay, let's see. Okay, exactly. Okay, this is the way to find it. using the table. This question one is not difficult, but the question A is maybe my mistake when I type the question. Okay, now we move on to question 2. Question 1C is similar. We don't need to care about this. Question 2. Okay, we have state the critical value chi square, that means chi square alpha, and determine the appropriate conclusion for a chi square test for goodness of fit using the given information. Okay. So now I will give you the question B. Okay, we have alpha here is 0.005 and k here is 15, right? And in this case, I will line GF here is 15 minus 1 is 14. And after that, I use the table to find chi alpha square. I use the table to find chi alpha square. It's 14, right? 14. 14 and 0.005. So that means 31.319. And after that, you will compare with the chi square in the question. Okay, chi square here is this value, right? Okay, and chi square is less than chi alpha square. Okay, because the 29 will be less than 31. Okay, when we have that, so we fail to reject the null hypothesis. Okay. Any questions so far? Okay, so the remaining questions, so you can do by yourself. Okay. And now I will make the attendance for you. Samia here, Max here, right? Hannah, up here. Laurel, Xavier here, Kylie, Bobby, Christopher here, Kaylee, Mackenzie not here, Robin not here, and Abdul Hamid, Elizabeth here, Chamachon Leaders, Kevin.
Yeah.
Kevin, okay, Kevin here, thank you. Nip, okay, James Liu, Jelani, Madeline, Australia, Laura, Matthew, Rick, Tyler, Maria Smith, Yossi.
Taylor.
Okay. Huh? Tyler here. Aliyah, Yossi, Steven, Maria, Thomas, Maria, Arthur, Tyler. Okay, thank you for your attention. Okay, have a good day.